Okay, so you are going to write a program to add two 16-bit numbers. Okay, which is, this is the number here, 2762 plus 1256. Okay, the result you need to put into R26 and R27. Okay, which is the R27 should have the lower byte. Okay, so you're going to write down how to do the program in order to add these 16-bit numbers. Okay, how to do that? Anyone? Okay, first thing first. Okay, so you need to, okay, so this is the numbers here. Okay, so you write down the numbers 2762. Okay, you're going to add with 1296. Apa ada garisan tu? Okay, since this is 16-bit numbers, okay, this is a 16-bit numbers, so you can divide it into 2 byte lah. Okay, low byte and high byte. So divided 2 byte. So this is a low byte and this is your high byte. Okay, and it says that the result of the addition will be placed at R26 and R27. Okay, and then it's tell you that R27 should have the lower byte. So R26 here, and this is R27. Okay, R26 low byte, R27 high byte. Okay, so you're going to do the addition operation. Okay, so since this one here, okay, before we, since this is a 16-bit, what you're going to do is for the lower byte, okay, you're going to use the ADD instruction. Okay, by using the ADD, you can add this low byte. What about the high byte? What instruction that you're going to use for the higher byte? Okay, you're going to use the ADC. Why? Because sometimes, okay, when you add this lower byte here, it will produce a carry to your higher byte. So you need to make sure that this carry is included in the high byte addition. Okay, that's why we use the ADC. Okay, and then because these numbers here, okay, 27621296, it's not inside of your GPR, so you need to load this number to your GPR first. All right, so sekarang ni, okay, if you can see here, okay, you need to put the result to R26 and R27. Okay, so why not we put this one here to R26 and this number here to R27. Okay, what about this number here, 1, 2, and 9, 6? Okay, you can put to any of your register lah. Okay, which is R16 for example, and 12 here you put to your R17. Okay, how to write the program? Okay, first load this number to your register. Okay, that you already assigned kat sini, and after that you add them together. Okay, so load LDI R26 with what number? 0x62. LDI R27. What number? 0x27. And then load I R16. OX96 and load I R17. OX12. Okay, after you already finished, put this number to your GPR. So what you're going to do, then you can do the addition process. Okay, you can use the ADD instruction. Okay, so which one we need to write first? Okay, is it ADD or ADC? Which one you going to write after this instruction? Okay, we're going to add do the ADD for ADD, and then after that follow by ADC. Okay, so ADD. Okay, make sure that the register is correct lah. R26 and R16. But now, because you want to put the result to R26, so this is your destination, R26 and baru je cakap tadi. Okay, dah salah. Okay, R16. And then barulah follow by ADC R27, R17. Okay, after you execute the last instruction here, what happen is you do this addition process. Okay, which is at 16 to 16-bit numbers. Any question? Ada soalan tak? For the first example, actually this is an exercise, okay? Tapi kita apalah. Okay, I give you as an example lah. Any question for this part? No question? Good. Then we go to the next examples. Alah, dia nak play animation ke? Tak perlulah. Okay, I just skip this part. Alright. Okay, so this is the second examples. Okay, now you are going to write a program to add this number here, 18 and 2917. Place the result in R25 and R24. Okay, and then R24 should have the lower byte. Okay, so what you're going to do is you need to find out the equation dulu lah. Okay, form up the equation. So you put 2917 plus with, okay, so this is hexa. H means that it is a hexa number. Okay, and then 1, 8. Okay, so you can, okay, and then after that, since the first number here is a 16-bit number, okay, so you can divide it to low and high byte. And this one go to R24, and this is R25. Okay, for this question here, you have two solutions. Okay, ada dua solution kat sini. Okay, the first one is the what we call here the shorter one. The second one is the longest one. Okay, let's look at the shorter one, and after that we do the longer one. Okay, so this one here. Okay, since this value is not in the GPR, so what you need to do is you need to load lah this value to your GPR. Okay, so I just put 17 ni dekat R24 and I put this one to R25. What about 18? Okay, so because I'm going to do the shorter one, okay, the shorter solution, so I just refer to my instruction set summary, and then I find out that there is a instruction called ADI W. Okay, ada instruction called ADI W, which is you want to add immediate to a word. Okay, so this is a one word lah. Okay, the first number here, 16-bit, it is actually is a one word. Okay, consists of 2 bytes. 2 bytes. Okay, but first, before I use this instruction, I need to what we call here to make sure, okay, the immediate value, okay, this value here is not exceeded 63. Okay, if you go to my slide, the ADIW slide, okay, there is a what we call a condition. It tell you that this immediate number, this K, which is a K lah, kita panggil K, not supposed to greater than 63. Okay, 63 ni dalam decimal. Okay, but this one here in hexadecimal. So what you're going to do is you need to convert 18 to hexadecimal. Okay, what is a 18 to hexadecimal? Can somebody press the calculator 18 to hexadecimal? Berapa dapat? Oh, sorry. Convert this hexadecimal to decimal dahulu. Okay, so you get 24. Okay, 24 is below than this value lah, 63. So you can use the ADIW. Okay, so what you're going to do is, okay, first load dulu lah. Okay, load the numbers. Okay, load IR24 0x17. Load IR25. And then followed by 0x29. And then ADIW. Okay, R25. R24 with this number. Okay, OX1. That's all. Okay, you only need to write down 3 lines of instruction. Okay, this is a shorter version lah. Okay, what about you going to do a longer version? Okay, you still okay. So what you're going to do is, okay, so this is the first number. Okay, just with the another colors. Okay, so this is the first number, 2917, the first number, and this is the second number. All right. So since this one here, you see the second number only have berapa bit? 8 bit. Okay, so what you're going to do is you need to put kat sini 00 lah, add another bit for the higher byte, because the higher byte you need to add with this number 29. Okay, then what you're going to do? Okay, so for the lower byte you can use the ADD, while for the higher byte you can use the ADC. Okay, before that you need to load this value 18 to another register lah. So contoh R16 and this 00 put to your R17 for example. Okay, and then write down your program. Load I R24 with 17. Load I R25 with 29. And then load I R16 with 18. And CLR R17. Okay, what is the CLR do? Anyone? What does CLR do? Apa yang CLR buat kat situ? Okay, you put 0 to R17. Okay, if you got confused, okay, okay, you can replace this one here, CLR R17 with LDI R17 with 0. Also same, sama. Equivalent. Mana-mana je yang kamu nak pakai. Okay, as long as your R17 is 0, okay, you can use either this one instruction or this instruction. Okay, both produce the same result. Okay, next what you're going to do, okay, we add lah. Okay, ADD R24. Okay, make sure that R24 is at the front lah. Okay, because you're going to put the value, the result to your R24. And it is R16. And then followed by ADC R25. R17. Okay, so this is the longer one. Okay, while this is the shortest one. Okay, any question for this one? Ada soalan tak? Alright, if no question, then we go to the next, what we call here, examples. Okay, so you are going to write a program to multiply 25 by 65 and give the answers. Okay. So you have this value, you want to multiply them. Okay, so what are you going to do? Macam mana nak buat? Okay, first load lah. Okay, load this value to your GPR. Okay, you can use any GPR starting for R16 to R31. So let's say like this one, I put R20 and this here R21. Okay, so I write down load I R20 with 25 and load I R21 with 65. Okay, next, what instruction that I'm going to use in order to multiply here? Okay, for the multiply, you have 3 instructions, which is MUL, MULS, and MULSU. Okay, which one that I'm going to use? Mana satu nak pakai? Okay, we are going to use the MUL. Why? Because this one it's the question not saying that this is a signed number. So we just assume that it is a unsigned number. So just write down MUL R20 R21. Okay, it doesn't matter. If you put something like this, pun sama. MUL R21 R20. Why? Why it doesn't matter? If you put MUL R20 R21 R21 R20, kenapa tak kisah pun? The way you put the destination and the RD and RR. Okay, because the result of this multiplication will be stored at R1 and R0. Okay, and then what you're going to do, just garap je lah. Press your calculator. Okay, make sure that your calculator in hexadecimal. 25 multiply with 65, then you get, anyone? Berapa jawapannya? Okay, so akan dapat mana saya punya ni? Okay, you will get E99. Okay, so which one will be stored to R0 and which number will be stored at R1? Okay, so in this case here, okay, so kita boleh divide it to low and high. This is a low and this is high. So R0 will get 99 and R1 will get 0E. Okay? Any question? Okay, if no question, then we go to the next, what we call it, examples. Okay, you are going to write a program to multiply 2 numbers, okay, as shown below, and give the answers. Okay, you have 2 numbers. Satu ialah F7, and the second one is 0, 2. Okay, you want going to multiply these 2 numbers here. Okay, for A, both are unsigned number. Okay, so what you're going to do is, okay, let's lah this F7. Okay, F7 you put to, okay, I put here R16. And this one here, 02 you put to R17. Okay, so write down the program LDI R16 0x F7, then load I R17 OX 02. Okay, and then what you're going to do? Okay, just use the MUL because this is both are unsigned number. Using the MUL R16 R17. Okay, so you just press the calculator, F7 multiplied by 2, you will get, berapa kamu akan dapat kat situ? Okay, so kamu akan dapat 1EE. Okay, so EE will be stored to your R0, while 01 will be stored to your R1. Okay, up until here. Ada soalan tak? Okay, for the unsigned number, you can simply press the calculator. F7 darab dengan 0 true. Straight away. And you get the result. Okay, if no question, then we go to this one. Okay, both are signed numbers. Okay, so again lah. Okay, you load this number to your first register and the second number to second register, and then by using the MUL S instruction. Okay, so F7 go to R23, 02 go to R24, and then MULS R23, R24. Okay, before you do the multiplication, okay, so you need to check whether this number is signed number or unsigned number. Okay, because you use the MULS, it says that both are signed number. So sekarang ni we going to find out, is it a positive number or negative number? Okay, for the first number and the second number. Okay, how to find out this one is either the positive or negative number? Okay, first, let's look at the F7. Okay, F7. Okay, what are you going to do? Okay, to check whether this is a positive or negative number. What are you going to do? Okay, convert to binary. Right? So F7 convert to binary, you get 1, 1, 1, 1 and 0, 1, 1, 1. This is F7. Okay, next. Banyak color kita guna banyak color. Okay, go to bit 7. Okay, so you go to bit 7 and check whether it's 1 or 0. If 1, you know that it is a negative number. Okay, so you know that, okay, since this is 1, okay, you know that this is a negative number. Okay, so since this is a negative number, so what you're going to do next? You need to find out what is the magnitude. Okay, the magnitude of this number here, F7. F7 is belong to what number? Okay, what negative number? Okay, what you're going to do is, you need to do a second complement. Okay, how to do a second complement? The faster way to do the second complement. Of course, you have the faster way and the slower way. Okay, the slower way, you change to first complement, and then after that, you add with 1. What is the fastest way to convert from this number to the second complement? Siapa nak tolong? Okay, you already learn in digital electronics actually, this one. Siapa nak tolong? Cepat. Okay, first, what you're going to do is, okay, from right to the left, daripada kanan ke kiri, find the first number 1. Okay, so this is your first number 1. Okay, and then copy this number. What about the rest? The rest you just invert. Okay, so it becomes 0, 0, 1, 0, 0, 0. Okay, so now you know that, oh, this is a 9. Okay, so since this is a negative, so this is a negative 9. Okay, F7 is actually a negative 9, equal negative 9. Okay, next we're going to check the second number kat sini. Okay, saya nak letak mana? Saya letak sini . Alright, so 002. Okay, 02, convert to binary, you get 0, 0, 0, 0, 0, 0, 1, 0. Okay, then check bit 7. Since this bit 7 is 0, then you know that this is a positive number. Okay, for the positive number, no need to do the second complement lah. So you just find out the magnitude. The magnitude is 2. Okay, next. What are you going to do? Okay, just multiply lah. Okay, so in this question here, untuk yang sign number, I advise you to multiply the decimal number. Okay, you press -9, multiply with 2, you will get -18. And after that, you convert to hexadecimal. Okay, so press your calculator now. Okay, -9 darab dengan 2, you get -18. From -18, you convert to hexa. What is the value that you get from your calculator? Okay, kamu akan dapat F, 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 E, E. Is it? Betul tak? You will get more, lot of F in front of this EE. So next, what you're going to do? Okay, which one will be stored to R0 and which number will be stored to R1? Okay, so starting from right to the left. Okay, so this is a lower bit and this is your middle bit and so on. Okay, so this is your R0 and this is your R1. Okay, the rest you just ignore lah because it's just to indicate that that is the negative number actually. Okay. Okay, this is for the MULS lah. What about the MULSU? Okay, the third one. Okay, dia bagi tahu mana saya punya third one tadi. Okay, it says that F7 is a signed number, 02 is an unsigned number. Okay, so my MULSU should be, okay, the first one here. Okay, so this is the R that have the F7. Okay, and then the second one here followed by R that have the 0, 2, because we need to follow this order. Okay, S and then after that U. Okay, so you write down load I R23 OX F7, load I R24 OX 02, and then MULSU. Okay, make sure that this is R23 and this is R24. Okay, so make sure that the position is correct lah. Okay, don't put MULSU R24 R23. Then the answer will be wrong. Okay, so jawapan akan salah. Okay, why? Because R24, which is this one here, become your signed number, and this is your unsigned number. So the result will be different. Okay, so sekarang ni, okay, what you're going to do before you to get the results? Okay, to find out what is the result. Okay, first, okay, S, your signed number is R24. So this is the signed number is R23. Okay, since this is your signed number F7, okay, macam tadi lah, you convert to binary 1111 0111 and check bit number 7. Okay, since this is a 1, so you know that this is a negative number. Okay, then convert to second complement. Okay, you get the magnitude. Okay, so you know that this is a -9. Okay, next for the unsigned number. Okay, since this is an unsigned number, so you know that this is a number 2 lah, definitely number 2 because it is an unsigned number. So you multiply with 2, you press the calculator, and then you get back the FFEE. Okay, you just get this value here, FF and EE, put to your R1, R0. Okay, any question? Ada soalan tak? Up until here. Okay, no question. Good. Next, we go to, I don't know what, soalan nombor berapa dah ni? Okay, next we go to the next question. Okay, show the result of following instruction. Okay, so you load I R20 OX04. Okay, so what you're going to do is, because next you're going to do the ORI. What is ORI? Okay, Dominic asking, for the negative value answer, we need to give answer in hex or decimal. Okay, we need to give the answer in hexadecimal. Okay, cannot give answer in decimal value. Okay, because our register R0 and R1 are in the hexadecimal. Okay, then Kevin Raman says that MULSU register operand limited to R16 to R23. Okay, please check back. Is it R16 to R23? Saya pun dah lupa. If yes, then we need to tukar lah the register here. Okay, cannot use the R24. You need to tukar to another register. Okay, and then Chong Zi Yin asking that if the question gives two number FF and FE, but didn't state which one is signed and is signed number, how are we going to choose which number is signed or which number is unsigned? Okay, contoh lah. This is for the MULSU case. Okay, so contoh R17 have FF while R18 have FE. Okay, then you write down MULSU R18 R17. So you know that. Okay, by looking at these orders here. Okay, R18 is your signed number. Okay, while R17 is your unsigned number. Okay. Okay, we need to refer to this order. SU, okay? The first one is signed number. The second register is your unsigned number. Okay, so R18 you need to find out lah. Tukarkan dulu dia punya tu kepada second complement to get the negative number. While FF, just take this value, which is 255. Okay, and then multiply the negative number with 255. Okay, because R70 is your unsigned number. Okay, next, we're going to see this one, yeah? Okay, ORI R20OX30. Okay, so you're going to do the logical or immediate with this value. Okay, so what you're going to do is, okay, if this type of question, you need to convert the value to the binary and then do the logical OR. Okay, so 0, 0, 0, 0, 0, 0, 1, 0, 0. Okay, you can use it by using the 8421 method lah. 8421, 8421. Okay, so this is 0, 4. And what about 3, 0? So 3, 0 is 0, 0, 1, 1, 0, 0, 0, 0. Do logical OR. Okay, you know that this is 0, 0, 1, 0, 1, 1, 0, 0. And the final answer should be 3, 4. Okay, next. Okay, show the result of the following instruction. Okay, you have this number here, 3, 5. Okay, change this 3, 5 here to binary numbers. 0, 0, 1, 1, 0, 1, 0, 1. And A and the I. Okay, do logical AND R20 with this value. Okay, OF 0, 0, 0, 0, 1, 1, 1. So what you get is, okay, you do the logical AND, so this become 1, 0, 1, 0, and this become 0, 0. So the answer will be 0, 5. Okay, next. Show the result of the following instruction. Okay, LDI R20OX54, LDI R21OX78, and EOR. What EOR do? EOR stand for exclusive or. Okay, you need to make sure lah the truth table. Okay, you need to get the truth table of exclusive all lah. Okay, so this is A, B, and this is your F. Kosong kosong will produce 0, 0, 1, 1, 1, 0, 1, and 1, 1 is 0. Then after that, you can find out the answers. All right, the results. Okay, 54, this is a 54. Okay, by using the 8421 method, okay, you can get the binary numbers. Okay, 7, 8, okay, this is a 7 and 8. Okay, do exclusive or 0, 0, you will get 0, 0, 0, 0, 1, 0, you get 1 by referring to this table here. Okay, the table down here. Okay, 0, 1, 1, 1, 1 is 0, 0, 1 is 1, 1, 1, 0, 0. And then the answer will be 2. 8 tambah 4 is 12. 12 change to hexadecimal, you get A, B, C. Okay, so the answer will be 2C. Okay, any question? Okay, for the last three question is just for the logical punya lah. Okay, logical question examples. Okay, as long as you know the truth table of your logical function, then you can answer this question. Okay, this one here. Okay, you are going to write a simple program. Okay, simple program. Ingat simple program to perform 60-bit arithmetic operation as follow. Okay, kamu nak tambah this number to this number, 60-bit number, and then subtract this with this number. And it says that place the result into R23 and R22. R22 should have the lower byte. Okay, how to do that? Macam mana nak buat? Okay, so you ni lah form the operation, the equation dahulu. Okay, so this is mana saya punya ni? Where is mine? Tadi Sorry. Okay. So this 1, 2, 2F. Okay, plus with 3, 4, 3, 8, and then put the result to. Okay, since this is a 60-bit number, okay, divided to low and high lah. Low, high. So this go to R22, and this is R23. And then after that, you minus with 3, 4, 3. Sorry, not 3, 4, 3, 8. 1673. Okay. Okay, so then what you're going to do? Okay, identify the register that you want to put for all of these numbers here. Okay, so yang ni kita letak dekat R22. Why? Because we want to put the result to R22, and this is put to R23. What about this one here? Okay, you can put to R16, and this is for R17. Okay, what about this one? Okay, this one I can make it as an immediate value. Okay, by using the SUBI. If I don't want to use the SUBI, I can put it to another register lah. So this is a R18, for example, and this is R19. Okay, and next, what I going to do? Okay, mula-mula I need to find out lah the instruction that I'm going to do for each of this operation. Okay. Okay, so we use the other colors kat sini. Okay, so this one here, untuk buat this one, so I use the ADD, and this one is ADC. How about this one? Okay, I can use SUB or SUBI. And kat sini, I can use the SBC. Okay. Okay, because this one here, you're going to subtract R22 with 73. Okay, you can use either SUB. Okay, subtract within two register or subtract with the immediate value. Okay, and then this one here, you need to subtract with the carry lah by using the SBC. Okay, why? Because somehow, okay, manalah tahu, okay, sometime after you subtract this number here, you might want to borrow from the higher byte. So that's why we need to put there, to use the SBC at our higher byte. Okay, next. Okay, write down the program lah. Okay, first LDI R22 OX2F LDI R23 OX12. Okay, this is the first number. Load I R16 with 0x38. Load I R17 with OX34. Okay, so this is a second number. Okay, next, the third number. Okay, load I R18 with OX73. Load I R19 with OX16. Okay, this is the third number. Okay, next. Okay, after I load this number here, all of this number to this register. Okay, so what you're going to do is, next I'm going to perform the arithmetics lah. Okay, the addition and subtraction. Okay, first we do the addition. Okay, we use the ADD instruction followed by ADC. Okay, so ADD R22 with R16 followed by ADC R23 with R70. Okay, this is for the addition. Then last but not least, okay, subtract. Okay, I put here SUB. Okay, R22. Okay, make sure R22 Okay, because you're going to put the result to R22 and R18, and then followed by SBC R23 with R19. Okay, that's all. Any question for this programming part? Okay, after this, which one is? Okay, so yeah, and Zhao asking that can he use both ADC? Yes, you can use the both ADC, but with a but, okay. If you want to replace here, okay, you're going to use this one here. Okay, you want to replace with ADC, but you need to insert another, what we call here, another instruction, which is sekejap saya cari dulu dia punya instruction, takut salah. I need to clear my carry. Okay, the first carry. Where is my first carry? CLC. Okay, by using the CLC. Okay, so I need to add this instruction. First, clear my carry, and then I use the ADC. Okay, because why? The first carry here. Okay, this is your carry. The first carry is 0. Okay, that's why I need to clear my carry. Because somehow, manalah tahu, okay, at the top here, you have the C equal to 1. And if you don't clear your carry here, so the carry will be included in this instruction, which is wrong lah. Okay, so that's why we need to put CLC. After that, you can use the ADC. Okay, any other question? Ada soalan lain tak? for this programming? ADIW. Okay, for this example here, you cannot use the ADIW. Why? Because this number here is greater than mana. Sorry. Okay. 33438. Okay, is definitely greater than 63. So you cannot use the ADIW. Same to this SBIW. Greater than the apa ni? The required value kat situ. Okay, as kalau this value here is smaller than this, yes, you can use the ADIW. But this one is definitely greater than 63, so you cannot use the ADIW. Okay, if no question, okay, we're going to do the last example. Okay, this is taken from your test or test. This is taken from the previous test, if not mistaken. Okay, this is the kind of question, analysis question that will be asking in your test or in your final exam. Okay, so given the content of the register below, okay, given that R20, R21, and R22 is 90, 82, and 10, okay, you're going to find the result after executing the following instruction. Okay, and it says that these instructions are not executed sequentially. Means that every time you do this multiplication, you need to take back the initial value ke atas ni. Okay, I give you 10 minutes. After that, we discuss the answer. Boleh ya? Alright, so given that this is the register value, R20, R21, and R22, and then you're going to find out what is the value after you execute this instruction here. Okay, so first thing first, okay, kat sini what I'm going to do is, okay, because this is you have MUL, MULS, MULSU. Okay, so why not I find out, I need to find out the value in the positive number and the value for the negative number. Okay, for R20, okay, so I convert this one here to binary. Okay, it will be 1001 and 0000. Okay, so this one here, if it is a positive number, unsigned number, so this value equal to berapa ya ini? In decimal. Okay, 1444. Okay, I don't have a calculator. Okay, so the answer, the result here, it depending on you lah. If you give the wrong answer, then the result will be wrong lah. Okay, and then let's lah. Okay, if this number R20 is a signed number, so I need to check bit number 7. Since this is bit number 7 is 1, so I know that this is a negative number. So what I'm going to do is, I need to convert to second complement. Okay, first find the first number 1. Okay, so this is my first number 1. So I just copy back this value here. Okay, and then after that I invert and change to what we call here binary, to decimal. What is the value for the negative number kat sini? Okay, 112. Okay, so positive number is 144, while negative number for the unsigned number is negative 112. Okay, what about A2? So A2 is 1010 0010. Okay, and then this one, if this number here is a positive number, it is equal to berapa? 162. Okay, and then we check if this one is a negative number, since this is a bit 7 is 1, so you need to do the second complement lah. Okay, so find the first number 1, this is your first number 1, copy back the value, and the rest you just invert. Okay, and then you get berapa kat situ? Negative. What is the magnitude? Yes, negative 94. And last but not least, your R22. Okay, R22 is 0001 000 0. This is equal to berapa? Okay, 16. Okay, since this is a 0, so even though dikatakan so it is a sign number, since this is a 0, this number is still in positive value because the sign number is 0. Okay, so this is the numbers here we need to consider before we proceed with this, what we call here, instruction. Okay, first, MUL. MUL means that you're going to multiply sign with unsigned number. Okay, so kat sini you're going to multiply R20 with R21. So R20 is 144. Multiply with 162. You will get berapa? Anyone? Okay. 5B20. Okay, you will get 2, okay, this is 23328. Convert to what we call here hexadecimal, you will get 5B20. Okay, all of you get this answer, yeah? Okay, the first one is the straightforward lah. Okay, what about the second one? MULS R20, R21. Since this is a sign number, okay, so we need to go to R20. R20 for the sign number is negative 112. Multiply with R21 also sign number, which is negative 94. Okay, you multiply this number, you will get negative, multiply with negative, you will get positive number, correct? Okay, so what is the answer kat sini? Okay, 10528. Okay, you will get 10528. Convert back to hexadecimal, you will get 2920. Okay, all of you get this answer, yeah? Okay, next. Yeah?
I cannot understand what R1 and R0. Supposed to be stored in R20, right?
Okay, R0. Okay, since after you, okay, this is 10528, you convert to hexadecimal and then it will produce 2920. Is it correct?
Yes, right.
Since this is the 16-bit number, okay, so you will divide it to low byte and high byte. Okay, for the multiply instruction, it says that the answer will be stored to your R1 and R0. So R0 will have 20, while R1 will have 29.
Thank you, Doctor.
Okay, welcome. Okay, next, MULSU. Okay, one is a signed number, the second number is unsigned number. Okay, R20, signed number is a negative 112. Multiply with R21, unsigned number, which is 162. Okay, you multiply this one, you get negative number. So what is the negative numbers? Okay, you will get 18144. Is it correct? Okay, and then convert to hexadecimal, you will get F, multiple F, banyak F ni. And then followed by, what is the value? B920. Okay, so now you need to figure out which value will be stored to R0 and R1. Okay, so we take from here lah. Okay, from right to the left. Okay, so this go to your R0, this will go to your R1, while the rest you just ignore. Okay, so dia akan masuk. The value is B9 go to R1 and 20 R0. Okay, what about this one here? MULS R21, R22. R21, Okay, this is a sign number, yeah. R21, the sign number for R21 is negative 94. Multiply with R22. Okay, R22, even though this is a sign number, but because this is a what we call here, the bit 7 is 0, so the magnitude is 16, which is a positive number. So negative 95 multiply with 16, you get berapa kat sini? Okay, 1504. 1504 convert to hexa. Okay, so you will get, okay, so if you press the calculator, what happens is you press the calculator negative negative 94 multiplied with 1, you will get F, 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 okay, and then followed by A20. Okay, so now we're going to figure out which value will go to R0 and R1. Okay, starting from right to the left. So this go to your L, which is your R0. And this one we go to your R1. So the answer is FA20. Okay, if you put 0A20, your answer will be wrong. Okay, it's supposed to be FA20. Okay, and last but not least, MULSU R22 R20. Okay, R22 will be your sign number. Okay, so this is your sign number 10. Since 10 is positive number, so this is a 16 multiply with R20. R20 is your unsigned number, so you take the positive value lah, which is 144. Kamu akan dapat berapa di sini? 16 darab 144. Okay, you get 2304. Convert to convert to hexadecimal. Is it that 2304 is a hexadecimal? Oh no. Okay, so you will get 0900. Okay. Any more questions before we stop for today? Okay, if no question, we finish module 5. Okay, next week we'll continue with module 6. All right, so thank you, class. The answer, okay, I will upload the answer in my website. Okay, you can go to my website, okay, this evening. Okay, if no question, I think we'll stop here. Okay, I will share the attendance links again. Sekejap, ya.